Hello students and friends, welcome to my YouTube channels. Today I am going to solve heat conductions through composite hollow sphere problems. Previous video already we discussed formula regarding the hollow sphere, composite hollow sphere with conduction and convection. But this problems only conductions through the composite hollow sphere. So what is the problems they given? First we'll go through the problem. A hollow sphere, thermal conductivity given 65, inner and outer dia they given 120 and 350 mm, covered with the 10 centimeter layer of the insulation wall. So see here, this is the hollow sphere, R1 R2 hollow sphere, thermal conductivity they given 65 and 10 mm covered. This thickness is 10 mm. This thickness is given 10 mm, covered by the insulation. Whose thermal conductivity they given? Suppose you are taking thermal conductivity of hollow sphere Ka. Suppose you are taking Ka. So this is will be Ka. This will be the Kb. Where is this? Here this is Ka. This will be Kb. Just I assumed. Or you can write K1, K2, nothing wrong. Okay. So here T1, T2, T3 we taken now. So okay, keep it like this, Kb and Kb. So inner and outer temperatures they given. Inner and outer temperature they given 550 degree respectively. Then they are asking heat flow rate. Heat flow rate. So see this R1, R2, R3, this is radius I taken, all the data I represented here. So only one formula will be there, 4 pi T1 minus T2, R2 minus R1 divided by thermal conductivity of the composite block, R1, R2 radius. How this coming? If we are taking the one hollow sphere, see this, how this formula is coming. Suppose I taken the hollow sphere, this is R1, this is R2, this is thermal conductivity K. This will be the temperature T1 and outside temperature will be the T2. So how we are getting this formula? So all the composite wall, cylinder and sphere, already formula I derived. How this formula is coming? From the Fourier's law of heat conductions only. All the formula is coming Fourier's law of conductions only. What is Fourier's law of conductions? Q is heat flow. Q is equal to minus Ka dt by dx. Once I will give the dx, that means this is the plane wall. Plane wall thickness is, we are taking dx. So we will give the dx. So we will get the, okay, just you look here, dx. If we'll solve this q dx equal to minus Ka dt. So you will get here q. Suppose if this integrate 0 to L, temperature T1 to T2. If we'll integrate here, what will get? Q is equal to dt na minus. If we'll write dt means T2 minus T1. If we'll write overall temperature T1 minus T2, L by Ka, L by Ka. What is this one? This is thermal resistance for the composite wall. If one wall, two wall, three wall, will add, na, the formula will come. So this is the composite wall. Now you see for the composite cylinder. Composite cylinder, what will write? A is equal to 2 pi RL. 2 pi RL, capital L, we are taking a capital L. If you will solve, you will get the thermal resistance again. What will thermal resistance will get? You will get overall temperature difference by ln R2 by R1, then 2 pi KL. 2 pi KL, you will get this value. This will get the thermal resistance for the spherical. Check it this. I think this will come. If now we are going to take the sphere for this particular problem. So A is equal to, will take 4 pi R square. So now we will substitute A is equal to 4 pi R square. What is Q will come? Q will come 4 pi temperature, no? 4 pi T1 minus T2. Suppose T1 minus T2. What will come? This will come R2 minus R1 by Ka, thermal resistance. Suppose 1, no, K, right, only K, R1, R2. This is the thermal resistance. What is this one? Thermal resistance for the hollow sphere. Now here hollow sphere and insulations also is there. So for one 1 not T1 minus T2, 2 not T1 minus T3, that means this will be the overall temperature. This will be the overall temperature. Now here R2 minus R1, K, R1, R2, then R3. Next will go R3 minus R2, K2. Suppose this is second block or KA. KA block I taken na A. Then KB R2 minus R2 into R3. Now we'll substitute, we'll get the answer. So this formula only required. So these things I explained for your concept. Once like this problems will be there, this formula will be available in the data book if you are writing the UG exam. If you are writing any competitive exam, you have to derive this. 2 minutes it will take time. You derive and you get the formula. But if college UG students directly will be there in the data book. But for competitive exams, you have to derive. So that only already previous video we given formula analysis, formula derivations, how to get the only area if will change, you will get the different thermal resistance. So overall temperature by thermal resistance will be the heat flow. So okay, now you substitute this value here. 4 pi T1, T1 500 plus 273, 773 minus 50 degrees Celsius plus 273, 323. Now R2 is here 0.175 minus R1 0.06 divided by thermal conductivity. How much is given? 65 into R1 0.175 into 0.06 plus second one R3 0.185 minus R2 0.175. Check it the value. This is 10 into this same into 0.185 minus 0.175. So both we substituted this value. Both value we substituted. So check it the value 0.175, 0.06. Okay. Then this 65 the given. Then 0.175, 06 correct. Then R2 minus R1. Then this. Now if we'll solve this, Q we are getting 28.59 kilowatt. 28.59 kilowatt. So if you will get watt means very big answer will come. So divide by 1000 it will come kilowatt. So for this particular problem, if you know the formula analysis, this formula, how this formula is coming, if you know, substitute this given value, you will get the answer. So okay, for UG stance will be little less difficulty. Why? Because this formula will be there in the data book. But for competitive exam, this formula how will come? So very simple techniques. Take the Fourier conductions of the Fourier's law of conductions formula and substitute A equal to 4 pi r square. You will get the thermal resistance. Numerator will be overall temperature difference. Divide by total thermal resistance, get the answers. Okay. Okay, students, watch this video and subscribe the channel. Okay, thank you.